Structural design project. 3D printing and computer-aided design. Two objectives of the project. 1. Provide an opportunity for students to create an innovative design through the application of computer software and verification through 3D printing and model load testing. 2. Promote flipped classroom pedagogy and enhance students' ability to learn independently. In this project, students are required to design a framework with maximum stiffness, yet minimal amount of material. Given the geometric constraints, they can explore different configurations through the use of a computer software. Space gas. To promote flipped classroom pedagogy, we made several tutorial videos of all necessary software, including Space Gas, FreeCAD, and FlashPrint, for their independent learning of the software and the 3D printing process. To compare various designs, they need to print out their designs using 3D printers. Load testing would be carried out to find out the best design among all submissions. Here are some examples of student submissions. For this group, they started with some very basic framework layouts. Then, they tried to add extra beams in both directions in order to find the most efficient framework. This is another group's approach. They tried two types of framework designs. Then, they chose a better one and tried to improve this particular design. This group's design is one of the most efficient among all submissions. We have a focus group discussion for some students to express their comment of this project. Here are some interesting students' feedback. 1. We developed the model through trial and error, based on the given assessment criteria. 2. It is interesting to learn some new technology. 3. It's not like a conventional course assignment. We have more room to create and develop our own idea. 4. The project can be done individually instead of a group work. There are several questions about this project in the course evaluation survey. In the 5-point rating scale questions, the mean scores of the feedback are higher than 4. This project is supported by the Teaching Development Grant, City University of Hong Kong.